workers?
Yes.
Welcome to class today. I'd like you to take just a look without touching at the materials at your table. And raise your hand if you think you can tell me a little bit about what you think is going to be investigated today. What are you noticing about the things on your material? Maybe something you can tell me about them. Yvonne? Okay, so you think some of the objects on there might reflect what? Sunlight, okay. Anyone else see anything on the table that might give us a clue as to what we're looking at today? Johnny?
Measuring.
Okay, maybe measuring because you see rulers on there. Okay, what else do we see? Raise your hand if you have a response. Okay, Yvonne again.
Mixtures?
What's that?
No.
Oh, mixtures?
Experiments.
Oh, experiments. Yanni?
Capacity?
Okay, oh, capacity. Excellent, I love that word because you see what?
Like.
You see the beakers? Okay, awesome. Okay, and Tiandre?
To try to see if you can see through all these things.
We want to see whether they are transparent.
Oh.
That's one thing we can look for. Okay, great. Well, guys, we're actually going to be doing a choice, and your table or your team at your table is going to get to decide what investigation question you want to answer. So, in order for you to decide that, in just a minute, I'm going to give you a couple minutes to just kind of play around with materials and figure out which question it is that you want to investigate. Okay? But you're right, Yvonne, it does have to do with light. And you're right, Yanni, it has to do with how, and Tiandre, about how light works and what we can learn from it. Okay? So, Tiandre, will you please turn off the last two light switches, leave on the first one? Okay, so up on the board, I'm going to show you 3 possible questions, and when you're doing your just kind of playing around, I want you to decide which of these questions that you and your partner want to answer, okay? Your partner is going to be your corner partner, so I'm going to go ahead and have you, if you don't mind, come move up here and be her partner. And so your corner is going to be here, and here, and there, and there. You two, you two, you two, you two, you two, and you. All right, great. Okay, go ahead and pass out a notebook, paper, and a pencil to each team. Okay, because in a minute you're going to be deciding which of these questions you want to investigate. Okay, here is our first choice. Okay, your first choice is, when placing 2 mirrors, I don't know why this is so dark today. Just a moment, let me try this.
Probably you need all of the lights.
Yeah, I don't know why. It doesn't normally come up that dark.
Do you need the lights here?
No, usually that's the one that does it. Oh, there we go. That's much better. All right. When placing 2, I'm sorry, by the way, I didn't even introduce you to Charlie. Okay? This is Charlie. You'll notice at every table that you have 2 Charlies, 1 for each team at your table, okay? So, when placing 2 mirrors in a hinged book formation and placing Charlie in the middle, how will the angle of the mirrors affect the number of reflections that you see of Charlie? So, for example, if I have Charlie here, would you hold him, please? And I have this angle, and you look in the mirror, do you see more than one Charlie? Will you look down that mirror? Yes? Okay, if I do this, does that change how many you see? Alright, but look down there. Okay, does that change how many you see? So that's one investigation you can do, is how does the angle of the mirror affect how many of Charlie's reflections? Okay, a second choice might be this one. When shining a light source on Charlie to make a shadow on the backboard, this is your backboard. You're going to have it opened at your table. You're going to be shining everything on here so you can see it. Okay? How does Charlie's appearance, when shining a light source on Charlie to make a shadow on the blackboard, how does the shadow change as you change the distance of the light source behind Charlie? So, for example, if you're shining a light at Charlie and you're this far away, is the shadow going to look different than if you have it this close? Or this close?
Yes.
Or this close? Well, that's one thing you might want to investigate. Now, can I move Charlie in that investigation? No, I can't because I'm doing how does a shadow change as you change the distance. How are you going to know what the distance is? What do you have at your table that will measure distance?
Everything.
What will measure distance?
Ruler.
Yes, ma'am. The ruler. So you'll have to know how far away the light is, right? How will you know how to measure the result? What is the result?
How much?
The shadow is the result. Good. Can you measure the length of the shadow?
Yes.
How do you measure that?
With the
With the ruler also. So that might be the investigation you want to do. How does the shadow change as you change the distance of the light source? Okay? The third choice is, how does Charlie's appearance change when viewed through different types of objects? Some objects are transparent. For example, we have the flat glass, right? We have water, and there's also, you may put water in these containers. Some of them are the half moon, and some of them are these. Okay? You have this kind of material. You have this kind of material. You have this kind of material. You have this kind of material, right? And you have this kind of material. So, in that case, are you going to move Charlie?
No.
No. Are you going to move the light?
Yes. No.
Yes.
Okay, here's my question. How does Charlie's appearance change when viewed through different types of objects? Is the light distance going to change?
No.
I know. What am I changing every time? What am I'm not changing the light. I'm looking through different types of objects. So if I am changing, one time I'm using wax paper, and the next time I'm using glass, and the next time I'm using construction paper, aren't I already changing something?
No.
Yeah, I'm changing what I'm putting between the light and Charlie, right? So can I change where Charlie is? Is it fair for me to change two things when I'm investigating? No. Can I change where the light is? I'm changing what's going in front of the light every time. Can I also change where the light is too? Okay, I can change two things in an experiment. Will that be fair? Will that be fair if I make one instead of just saying, okay, I'm going to put you two on two sides of the room and I'm going to blindfold you two? Is that fair? No.
Yes.
Yes.
Yeah. Wait, what did you say?
I said, is it fair that if I give you a test against somebody else and I said, all right, I'm going to put you on different sides of the room and I'm going to blindfold you?
No.
Is that going to be a fair test?
Yes, because I'm not going to.
Okay, if you are changing one thing, you cannot change anything else. Because you're seeing how does that one thing make a difference, right? So if I am changing the light, going back and forth, and I'm changing what I'm putting in front of it, that's not a fair test. So I'm going to keep the light the same place, and I'm going to keep Charlie the same place, and the only thing I'm going to change is what I'm putting in front, right? How am I going to let somebody know how those changes, what changes it made when I put different stuff in front? Can I measure it? Is there going to, maybe if there's not a shadow? Sometimes in science, we don't have to measure. Sometimes we just draw and record our observations, right? Can I draw a picture of what I see? Yes. So if I have one picture of what I see when the glass is there, and when I put the water in front, the picture looks different, guess what I'm going to do? Am I going to draw the same picture I did before? No, I'm going to draw what that picture is, and then I put something else in front, then I'm going to draw what I see. Do you see how that's going to show me how the different materials are affecting what I'm seeing on my board, right? Okay, so those are going to be your three choices. Either you can do the mirror test, where you can see how his reflections change with the angles. You can do the light distance test, where you keep Charlie the same and you measure the shadows as you move the light. Or you can do the type of material material test where Charlie and the light stay in the same place, and you change the materials that you put in front of the light and see how that affects Charlie's image. Okay? So I'm going to give you about 5 minutes now to kind of play around and see which one of those questions you and your partner want to investigate. So you need to take your board. It needs to be up here, and everybody doesn't move to one side of the table. Okay?
Things from the ground, the clay?
Okay, remember you have one partner. That is the one on the corner with you. You do not have to do the same question that the other partners at your table are doing. You may choose a different question. Whatever is interesting to you is the one you should do. Okay, you're not doing the investigation yet. You're just kind of deciding what it is that you want to do.
When we put 2 lights, there's
One light, because everybody else has one light.
Yeah, but we have 2.
I know, but that's because this is a table of 4. Okay, go ahead and take one off. Okay.
That was
Can you turn it off? Okay, remember, you're just kind of deciding which of these you want to look at. And we're going to decide, and then we'll do the investigation in a few minutes. Okay, make sure they have a spot. There you go. Whoops. Guys, please be gentle with my materials. Okay, we have about 1 more minute before we need to decide. Be talking to your partner. Decide which investigation you would like to conduct.
How is it? Is it mirror? Okay, let's try this. Oh, look. Mira, you can hold your hand right there. Mira, mira. You can see the head. Mira, look, you can see the head right here. Aquí en la reflection. Oh, look at it. It looks 3D. No. Oh, yeah, let me see. Shine the light on it. We don't have it. We don't have that one.
There it is.
Oh, yeah, look. It's 3D. And it's a rainbow. Oh, and it's cool. Oh, yeah. Oh, yeah, mira. Look how it moves. Let's do the animation. One that you just showed us. Oh, my God.
Okay, hold on, we're back. Yes, Stephen.
Look, it's Dierschke, a rainbow.
Yeah, I know.
Wait, where is it at? I lost it.
What makes that rainbow, do you know?
The light.
The light's going through? Is it going through air now?
Stop, Dierschke. You're making
Is it making a rainbow when it goes through the air or through the water?
through the water.
Through the water. That's right.
Oh, yeah, look. Right there. Do it more.
Okay, guys, I'd like to ask you to go ahead and set your materials back on the table. And we're going to make a decision. Okay, everybody have a seat. Oh, grasshoppers. I need everyone's hands free of materials and eyes on me. Thank you. Hi, beautiful. Nice to see you again. Okay, so here which says if you place two mirrors at an angle to one another and put Charlie in the middle, how does changing the angle of the mirrors affect how many of Charlie's reflections you see? Is there anyone who wants to do that one? Okay, moving on to the second choice. The second choice is, how does, when shining a light on Charlie to make a shadow on the blackboard, how does the shadow change as you change the distance of the light source behind Charlie? Okay?
Is that the light one?
That is the light, the shadow and light one. Okay. All right. Hands down. Okay. And the third one. Abigail, I need your eyes, baby. How does Charlie's appearance change when viewed through different types of objects? Is there anyone who wants to do that one? That's the one where you're changing the paper or the glass or the prism. All right, so I'm going to ask you if you can go ahead and take this again. All right, so I would like for person number 1 and number 4 to be the reporter for just a moment, and we're going to write down the question that you guys are going to answer. Okay? If you chose the second question, here's what you're going to write. Okay? Okay, let me open. Oh, way too big, isn't it? Okay. There we go. Okay. How does Charlie's shadow change when the light is moved? So I just simplified my long question into a short question. How does Charlie's shadow change when the light is moved? So, when you start your investigation on this one, you're going to have to put Charlie in one spot. So let me just make you a quick drawing. Here's your backboard. Okay? And I'm just kind of giving you a little etching here. So here is your Charlie. Okay? Alright. Then, if this is your flashlight, the first thing you're going to do is you're going to measure how far behind Charlie it is. Right? And you're going to do that using what? Your ruler. Good. Then, you're going to decide, are we going to move it closer or farther away? Am I going to move Charlie? No, I'm going to move, let's say I want to move it closer. Okay? Now, do you see how this is closer to Charlie? And I'm going to measure that, right? Okay? I can keep changing where the light is. Okay? So, let's say I want to do it farther away. Here's Charlie again. Okay, here's the light. And I would measure how far away he is, right? Now, what else am I going to need to measure?
Shadow.
Oh my goodness, I have brainiacs in here today. I'm going to have to measure the shadow. So let's say his shadow is like this. I'm going to need to measure how far the shadow is. Let's say the second time the shadow is like this. I'm going to measure how tall the shadow is. Let's say the third time, okay, the shadow is like this. Okay, so whatever the shadow is, I'm going to measure that. So a great way to organize my data would be to make a table. Okay, so I just really need 2 columns. Okay. Okay. Distance. Okay, that's how the light is, and the shadow. Okay, so the first time I do it, let's say I'm 10 centimeters away, it makes an 8 centimeter shadow. Okay, these are just examples. Then I put it 12 centimeters away. It makes a 10 centimeter shadow, etc., etc., etc. So that's the way you're going to have to record your data. Okay? So that is investigation 2. If you would like to do investigation 3, okay, you're going to put this. How does Charlie's image, if you're doing question 3, yeah, you're doing the 3rd investigation. How does Charlie's image change when different materials are put behind him, okay? In this investigation, okay, here is my board, okay, here's Charlie, and here is my light, okay? Now, remember, my light is not going to move, my Charlie is not going to move. The only thing that's going to change is what I put right here, okay? So, I might put a piece of glass right there. I might put a piece of construction paper right there. I might put a piece of wax paper right there. I might put a glass of water right there. Okay, do you see how I'm doing that? This is not changing, this is not changing, this is not changing. Just what's going here. How am I going to record that? Well, again, I can only, since I'm not measuring anything, I'm going to do my drawings. So, I would do this. I would label, I'm going to draw a picture of what I see. So, this is what I see, and I'm going to label this glass. So when I put glass there, that's what I saw. Okay? Then I'll do another box. Okay? Then I'm going to do this. When I put black paper, guess what I saw? When I put black paper between the light and Charlie, what am I going to see on the backboard?
Black.
Black?
Nothing.
Nothing! So guess what my drawing's going to have?
Nothing.
Nothing! Okay? When I put water, okay, alright, then what did I see? Oh, I saw a rainbow and Charlie in the middle, but he was kind of weird looking. Okay? You see what I'm saying? Okay, so those are the 2 choices you have. Does anybody have a question? All right, you're going to have 20 minutes, okay, to do your investigation. I want to see your results. I want to see either your measurements on a table if you're doing how does the shadow change when the light source gets closer and farther, or I want to see your descriptive drawings about how his image changes when you put different types of material between the light and Charlie. Okay, anyone have it? I'm going to turn off the lights. We're going to put our boards right back where we had them before. Okay? All right, and you guys have to be good about sharing with each other. Thank you. All right, lights are about to go out. Make sure your board is set up. Huh? You can choose either one. Doesn't matter. You can choose either one, whichever one you like. Okay, there we go. Okay, we have only 20 minutes, so you need to get right to work. I want to see science. I want to see good investigating. I want to see measurement if it's necessary. Yeah, you probably, the whiteboard needs to go with you so you can see better.
Yeah.
Bring the white, Yanni, I would put this whiteboard down there too. Okay. number 1 you have to measure?
No, right.
Oh, yes.
Yeah.
Yes.
So she doesn't believe me.
1 and 4 are the writers. 1 and 4 are the recorders. Okay.
Okay, grab Charlie.
All right. I love you guys. They're so...
Sí, pero si no hay más de los 12.
Yes, if that's easier. As long as you're working. Awesome. Okay, guys, you need to work with your teammates in a polite and cooperative manner. Hey, partner, why are we going under the table? Guys, I recommend that you bring the whiteboard down because you'll be able to see things easier. The whiteboard underneath, that's why I've had it there. Okay, because the brown isn't going to show the light up as well. Are you able to see the shadow that close? Is that where you want Charlie to be the whole experiment?
¿Yo ni hicieron esto? No. No, 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 así.
How they get scratched, baby. That's $5 right there. I don't treat your things like that. Okay. You guys, you cannot move the board because you're disrupting their side. Leave the board in one spot. Yami, please leave the board in one spot. Okay, I'm seeing a lot of good work. I'm seeing great teamwork here. Wendy and her partner are working hard. that shadow got? How did you make the shadow bigger? Oh, you got closer. Interesting.
Yolanda's pins are broken.
Okay, let me go get you a new one.
Excuse me.
Okay, Yvonne? Okay, which experiment are you guys doing? One or two? Okay, the second one with the shadow or the one with the materials?
The one with the shadow.
Okay, that one? All right. Look at the setup. Wait a second. Look at the setup. Okay. Where's Charlie supposed to be? Is he supposed to be... Is he supposed to be between the material and the board or in front of the material?
The material?
You need to put the material in. Okay, bring the material around. Charlie stays in one spot and never moves. The material needs to be in front of him on your side.
Hey, I make your sauce.
Yes, there you go. Okay.
How this is this called?
That's just called flat glass. I would just call it like window glass, flat glass, or plain glass. You can put flat glass. You can put window glass, plain glass. La lupa? La lupa? Hand lens.
12?
Hand lens. La lente mano. Hand lens. Lente. Hand lens. Ajá.
Ahí está.
Whoa. Charlie es grande. Ah, Charlie es poco. Ah, interesting.
El fío está acá, mira. Es que ustedes se ponen y se quitan. Mira, Leslie, le da otra cosa. Mira, aquí aquí está Charlie.
Okay, yeah, are you doing, how does Charlie's shadow change when light is moved? Yes. Okay, so you can do it like that, or you can remember the table I drew where you could show how far away it was? Okay, but you also need to measure how tall his shadow is, because how are you going to know what happened to the shadow as you got closer and farther away? Oh, very nice. Okay, now we have, is that how tall the shadow is or how far away the light is? A shadow, okay. Did you measure how far away the light was?
No.
Okay, how are you going to find a pattern?
Oh, we're supposed to be doing that too?
Yes, you're supposed to, right. Okay, so when...
you gotta start all over?
Well, I would try to get them to be these same heights again, okay? And when you get to 21, you'll know you to stop the light and then measure where the light is from Charlie. You're welcome. Woo, hi. Okay. Let's see here. All right. Oh, look at that. Close, far. Wow, looking good. Can you get me 2 more measurements? I want at least 5 measurements. Prism, P-R-I. And put this is a water prism. If you put water in there, it'll act like a prism. Okay, guys, we have about 3 more minutes because I want to talk to you about your findings.
37. antes era más así, pero ahora cuando yo me vi eso que así. Así, 28. Sobre
you used the glass, the pyramid, the rainbow paper, flat glass, water prism, foil. Okay.
This is a black.
Okay, can you just draw your boxes so I know that there was nothing there? Okay, just draw a box just like you drew boxes there for each of those. Okay.
If one is part of my
Oh, grasshoppers! Yes! Please leave your materials exactly where they are. Have a seat at your table with your papers. I would like to have a discussion about your findings. If your board is in front of you, just go ahead and put it down on the floor so I can see your beautiful faces. Should be off, and your material should not be in your hands except for your observations or your results. Okay. Now, I must say I'm very impressed with the level of professionalism I saw with several of the groups. They were taking their time. They were making accurate measurements. They were recording. So thank you very much for those of you who were on task the whole time. I think you're going to learn more that way, right? Okay, I want to kind of get some of the evidence that you came. If you look at your data, if you did the one with the measurements, I want you to look at your data, look at the numbers you wrote on your table, and tell me if you notice any kind of a pattern or any kind of a conclusion you can draw. For example, okay, did every time you moved it farther away, did the same thing happen? Or every time you moved it closer, did the same thing happen? Or did sometimes it got longer, sometimes it got shorter? So take a look at your data, and I'm going to ask one team to give me their data, and then we're all going to take a look at it. You going to go ahead and do that? Come on. All right. So I'm going to go to the back table. I think that they did the most precise measuring up there. You ladies over there. Thank you very much. Okay. So go ahead, and I'm going to, if you will bring your table up here, do you mind? That would be lovely. Wouldn't it be lovely? All right. Is my thing on? Okay, and so they came up with a system. They worked very well together. Tell everybody your name. Jocelyn and Yolanda. And okay. Jocelyn and Yolanda. All right, so over here, this is how tall the shadow was, and this was how far away the light was. Is that correct?
Yeah.
Okay, great. Can you guys see it? Is it on you? No. What in the world?
Can I turn it on?
Maybe my battery is running low. All right. So I'm just going to tell you right here. So what happened when you were 20 centimeters away? How tall was your shadow? 21 centimeters. Okay. This is the same distance again? Okay. Okay. When you were, right. All right. When you were 20, this must be this one then. Okay, does this one go here? This one go here? Okay, what goes with this one? Okay, so this is going on here. That one? So that was 21. That was 21. And that was like that. Okay, great. All right. Oh, here we go. Ta-da! All right. Can you guys see the screen? Okay, so when the flashlight was 46 centimeters away, the shadow was 17 centimeters tall. When the flashlight was 9 centimeters away, the shadow was 28 centimeters tall. So what does that tell you? That tells you the farther away the light, the what? Longer or taller, the shorter or taller the shadow? Shorter. And the closer the light, the taller it is. All right. For those of you who did the same experiment, is that the pattern you found? That the closer your light was to Charlie, the closer your light was to Charlie, the taller his shadow was.
Yes.
You did find that. Does anybody find anything different? No? Okay, great. Did you also find then that the farther away you were, the shorter his shadow became?
Yes.
Yes. So we would call that a conclusion. Your data is supporting the conclusion that the closer the light source to an object, the taller the shadow will be. Right? Okay. That's very good. All right. If I can have, I know somebody did, Claudia's team. You guys did the other one with the materials in front? Okay, can you bring me up your pictures, please? Thank you very much, ladies. Awesome job, my friends. Here, I'll give you guys $5. You guys work so well together. Very impressive. All right. Okay, so this one, we did the other experiment, and this one had the observational drawings on it. Okay? So, this says handleless glass. What does that mean? Which glass was that? Oh, okay. So when you use the hand lens, okay, la lupa, okay. So what are explain what you're seeing right here.
Like when I put that in the middle, it shows tiny and
So he had rainbows all over his hand? Yeah. Like Skittles? Yeah. No, okay. All right. And then when you have the prism pyramid, wow, in front, what did you see?
I didn't see this part, but this is the part that this part that's the other part outside, it doesn't show. So
Oh, it doesn't show. Okay, great. Now, when you look through the flat glass, did Charlie look any different?
No.
No. But when you look through the rainbow paper, did it look a little different?
Yes.
Oh my gosh, look what happened to Charlie's head in the water. I love this picture. Can you guys see that? Charlie's head is discombobulated from his body. How did Charlie's head come off? How did Charlie's head come off? You put water in front of him. Something must have happened to that light. Did something happen to the light when it went through water?
No.
It didn't? Interesting. Oh, you know. Yanni, what happened to it?
Maybe the light curved like...
The light curved. You are so right. The light bends is what we would say. And we call that refraction. Refraction, light bending action. Hiya! Remember that?
No.
Refraction, light bending action. Prisms and water and lenses too. Refract looks whack when that light comes to you. Refraction, light bending action. So water, yeah? Awesome. And I love this, guys. Oh, this is beautiful, beautiful. I would like to have everyone's copy of your results because I'd like to look over them. Please make sure you and your partner both have your name on it and put 4A on your paper so I know whose class it belongs to. Oh my gosh, I am so happy. Next week we're going to do a continuation of this experiment so that we can see what else light can do when it interacts with different kinds of matter. All right, guys, go ahead and make your